Good morning. My name is Sammy Nelson, head of product at dcbel. Today we're here at one of our installs so we can take a closer look at a home energy station. As you can see, installed outside. This is fully rated for indoor or outdoor installation. And then of course, one of the criteria is proximities to EVs, because not only is it a home energy management station, solar integrated, but of course the ability to charge two EVs, one in DC, one in AC. So that's why you see the vehicles here this morning. We're going to show you a little bit of how that works. But you know, the installers sat with the customers and understood their needs. Interestingly, they did have an EV charger here before, but the access and proximity to the device was less of a concern, because the beauty with this, unlike a lot of the conventional PV inverters or battery, is that you don't have a screen. So this gives really an opportunity to for the customer to stay aware, receive any notifications, track their progress, whether it's, you know, state of charge, or if they're in an energy program, how much time is left. Right now, as you can see, is we're only connected to the grid. There's nothing else. As I said, this is a part one of two installations. So they have home energy management and EV charging, and later they're going to be adding a solar and energy storage, and in fact behind this wall, which we'll take a look at as well. So you can see it's very neat and clean. The wall structure was already there. The customer took the opportunity to sort of install these new composite boards, but the installers took really time to tuck in everything neatly, so that from a street perspective or any visitors that come in, you're not seeing all of these electrical conduits or wires. So that's one of the things that we encourage people to do. So here's the continuation of the installation. You can see the back wall. So I mentioned the composite boards were installed for a little bit more of an appeal, but this will be completely enclosed. This here was put in for reinforcement. You don't need any more than that. We provide a whole wall mounting bracket, which can be mounted on any surface, whether it's concrete or wood. And then again, you can see here the attention that was given, each of the conduits neatly back into the service area inside the house, which we'll take a look at later. And then these are properly labeled according to our wiring diagram, so you know exactly how to run these wires. The other thing as well is that the battery is going to basically be put on a footing here. It's a 16 kilowatt hour LG Energy battery, so it'll be installed here, and then the whole wall will be enclosed. Both units, home energy station, as well as all of our devices, can be installed indoor or outdoor, and with the type of climate that we have, slate, wind, water, anything can basically resist to that. All right, so let's try a little EV charging while we're here. So let's connect this one here. So this is your standard level 2 charger that you'll find from home, connects 240 volts. As you can see, the charge starts automatically, which is a configuration. Both chargers now are set to automatic. The only reason they wouldn't be is if you'd have a schedule, which you can set in the app, or if you happen to be participating in a charging program, which is scheduled to start at a particular time, or of course based on your time of use rates. But otherwise, you can come in, let it charge, interact with the device, or as well on what we call our mobile portals for iOS and Android. We've got full remote control and telemetry. So here the stopping of the charge occurred, and then if I just hit start again, and then we do a quick GFI for security check, you can see that's passed, and then your charging takes place. So in the screen, you can see here, I'm drawing a little bit more from the grid now. So I'm at 5 kilowatt, barely drawing anything for the home. Most of it here, it's a 9.6 kilowatt charger, which of course uses the onboard inverter. So one of the unique features of Home Energy Station is that we have dual EV charging. So I'm connecting here this wonderful electric car. It's got CCS Type 1 for North America, but we support all standards. You can eventually updates for NECS, and in Europe will be Type 2. But this one here is full DC. So unlike this, which charges at, uses your standard 240 volt, this is a full 400 volt charger, much like you see in your public chargers. So the requirement here is we need to do a little bit more in terms of safety checks. So we run a full isolation monitoring, and then the communication between the car and the EV, and everything is good. Then you get a green light. And just like the AC charging, this one is set to auto. So you can see here the energy transfer started, and we're drawing a full 11 kilowatt hour based on what the EV is requesting. So this here is also what we call our power boost mode. So it's using our both digital multi-level inverters rectifiers. So it's basically taking that AC grid electricity, converting it to DC, and sending it straight to the vehicle. So unlike the level 2 charger here, where we're sending it and the charging is actually taking place in the vehicle, we're bypassing that, going straight to the battery and getting upwards of 25% efficiencies. So as you can see here, 11 kilowatts of DC, but in reality, if you're looking at effective AC, because we're not doing any conversion, that's the equivalent of about 15 kilowatts. The other thing also to note here is I was in power boost. So if I can simply click on this button to eliminate one of the digital multi-level inverters, so your power will be cut down by 50%. So unless you're in a hurry, you don't need to use that power boost. You just put it in, you put your desired state of charge, and then ARA will take care of charging your vehicle on time. So in this little utility room, you've got all of the auxiliary devices for home energy station. So first the DB bridge, which its main function is to island the home whenever there's a blackout. And then you'll see how here the setup was done. So the critical loads carried over from the other main panel rooms with its own junction box. And then this is the access, if you recall, all of the conduits going to the back of the wall, so that for the future install of the battery and the solar, and then of course the power shield module. So everything is nice and neatly tucked away, doesn't take any room, easy to access when you need it to. All right, so we're downstairs here where the main panel is located, just on the other side of the service entry. So the installer's job in speaking with the customer was to kind of identify which of the critical loads. I believe the key things, of course, Wi-Fi, some of the plugs and the appliances in the kitchens were kept, in a couple of key rooms, including the office. And then, of course, the sump pump for them, which was important. Outside of the main panel, which you see here, you see this little unit down there is our DB tempo. So it's basically with the current sensor, and that's what measures all of your power in and out of the house, so that we can always balance your load and know exactly what's going to the grid and back. So what we're going to do now, if you recall, we were charging, and both the AC and the DC are both charging. The AC is connected directly to the main panel. Okay, so in a blackout situation, you'll have one of two chargers that are available to you. And what we're going to do is we're going to show the blackout capability. So I'm going to shut off the main. Okay, so you can see some of the lights already went off. So that was not on a critical, so that's good. So then we can go back outside and see how ARA's behaved. All right, we're back outside. The power to the house is off. So as you can see here, we're still drawing from the electric vehicle. So vehicle to home in blackout mode. We're still disconnected from the grid. We went to turn on a couple of lights, so you can actually see here we're barely 2 kilowatts. It's not a lot of things going on. There's nobody home. But we're in our own private grid here. So we got full 100% independence. And if we were to turn on other critical loads, of course, the power would go up. So we're currently in ARA's grid forming mode because the V to H and the V to G work in both modes. So meaning that you could be discharging your vehicle while the grid is off, as we're seeing now, but also when the grid is connected. And why would you want to do that? Just basically to offset your energy import, let's say at dinner time, peak shaving, so that you reduce your electricity consumption. So what we're going to do now is we're going to go back and turn on the grid. And we're going to let this run through, and so you'll see the sequence of grid reconnection. All right, so we've just turned the main breaker back on, and currently ARA remains islanded for safe and grid reasons. So typically, depending on your service territory, you got to wait about 5 minutes. So your critical loads are still powered from the main source, so in this case it's the vehicle. And then the switchover takes a few minutes, and when that happens, we notify the user, and then the lights automatically go back out. So ARA is operating currently in grid forming mode. So this digital multi-level inverter will create its own sine wave when the grid reference is not there. But in the same fashion, it can also follow the grid, and we can also draw from the vehicle, you know, in the middle of the day when the grid is on, whether you're doing vehicle to grid or vehicle to home, to offset your energy consumption. So as you can see now, we're almost nearing the wait period of 5 minutes. So in about 10 seconds or so, ARA will reestablish connection with the grid. So the DB bridge, as we call it, our smart islanding switch, basically now reconnects. And so now you're drawing power as you were normally. So as you can see now, we're back on power, and automatically the EV is starting again with auto charge, so that if you're in the middle of the night, all of this happens, and you needed your car in the morning, it will be charged when you wake up. All right, so we've taken a couple of opportunities to charge these EVs, one through AC charging and the other with DC, and also charging both vehicles at once. And then we also took the house offline, powering the critical loads using only our EV. And if you look now, we are also in another state where we're discharging the vehicle, also vehicle to home, but this is really a grid following. So as you can see, first of all, the grid is still on. In fact, we've got an excess of power coming from the EV, so every now and again you'll see that excess is being sent to the grid. So the big key difference is when we were looking at Blackout, the inverter, okay, the digital multi-level inverter, had to create its own sine wave because the grid wasn't there. And now we have a grid reference, so we can easily follow the grid and still discharge a vehicle. So when would you use that? Basically to offset your energy consumption. So especially during peak times, you come home, the car has got a large state of charge. This, in fact, has got 111 kilowatt hours of capacity. So right now, at peak times, this would come on automatically. Your car's connected, so you're not only connected for charging, but it becomes part of your home energy mix. And you can see here, it's basically sharing some of that load, and the excess from time to time is going back to the grid. I hope this video about the product and user experience was helpful to you. Thanks for watching.